tomorrow. There are 3 separate parts of this, so this question is 3 points, I believe. And it's graded on a rubric, and so there's no half points, right? So if you do everything in grading mode, but it's all right, there's no minus half, you're going to lose a point. All right, so first thing it says is that I want to draw the picture, so I'm just going to do that up here. I'm going to plot the point -6, +5. So I'm going over 6 and up 5. -6, +5 is putting me somewhere in quadrant 2. If you plot the point wrong, you're in the wrong quadrant. And if you're in the wrong quadrant, your final answer is wrong, right? So you got to be careful in plotting the point. -6 is x, +5 is y. That puts me in quadrant 2. So now I'm going to connect that to the origin, and then that's called my terminal side. The ultimate goal in this problem is to figure out what that angle is. So when it says find the standard angle, that's that angle. That's what I'm looking for. Are we okay with that? All right, so then I would, from here, draw my reference triangle. I'm going to use the x-axis, and then I'll just go straight up to my point. And what I know about this is I went left, -6, and up 5. The signs of the coordinate point should be on your triangle. So that's a -6. It's not a +6. I went to the left. Now, distance-wise, it's just 6. But in terms of the triangle, it's -6. Then I need to find the hypotenuse of the triangle. I'm going to use Pythagorean theorem for that. So I'm going to do 5 squared plus -6 squared equals c squared. So 25 plus 36. You get 61. So part 1 says draw the angle and label all 3 sides. So your first point is coming from drawing the triangle in the right quadrant and getting the root 61, okay? There's no half points. So if you draw the wrong triangle, but you still got root 61, you're still not getting credit for it, right? You gotta make sure it's in the right spot and the root 61's right, okay? Point 2 says, find the exact value for all 6 trig functions, rationalize when needed. So keep in mind that I am referring to this angle that's called the reference angle when I'm filling this part out. So I know that sine is opposite over hypotenuse. So the opposite leg of the r is 5 and the hypotenuse is root 61. I'm going to rationalize that because it says rationalize when necessary. So this is 5 root 61 over 61. Cosecant is hypotenuse over opposite. So it's root 61 over 5. I don't have to rationalize that one. I would have to rationalize both. They won't be though. Because I'm giving you a coordinate point, meaning these 2 are whole numbers, the other one.
Yeah, I was just thinking like if
they could be. They just won't for an example like this. They couldn't be. Alright, cosine is adjacent over hypotenuse. So the adjacent leg is -6. Here's my hypotenuse. I'm going to rationalize that. I don't know why I wrote 54. I have no idea where I got 54 from. 61. Well, I'm multiplying by root 61, so I have -6 root 61 over 61. And then secant, boys, is hypotenuse over adjacent. So it looks like that. Tangent is opposite over adjacent. Opposite is 5, adjacent is -6. Cotangent is adjacent over opposite, -6 over 5. You are only getting point number 2 if all 6 are right. If you forget the negative, all 6 aren't right. You're not getting that point. There's no half credit here. It's a rubric. You either meet the criteria or you don't. So don't forget to label the side lengths with the negatives, right? All students take calculus tell me that in quadrant 2, sine is the only positive one. So there should be negative signs on all of the other ones. Sine is the only thing positive here. So it should be the only trig function that has positive values. Alright, so that's point number 2. Point number 3 is I need to figure out what question mark is. But in order to figure out what question mark is, I'm going to need that green angle. So to find the reference angle, I'm going to do the tangent inverse of 5/6. If you do tangent inverse of negative 5/6, you're going to see that that's wrong. I'll show you. So I know that a reference angle is an acute angle, meaning it's between 0 and 90 degrees. So I'm going to change my mode in my calculator to degree mode. And I'm going to do the tangent inverse of 5/6. If you accidentally keep the negative, you're going to see that it's not right. We're not working with a negative reference angle, right? So I just like ignoring the negative sign. The reference angle is 39.80. That's not the answer though. That's just the reference angle. So here's what I've got in my picture. Got this triangle. And I got that this is 39.8, but I want this. So together, red plus green is 180, right? So I can figure out what red is by doing 180 minus 39.8. $140.2. Now here's the deal. You either have it or you don't, right? It's a rubric. Now, however, if you plotted number 1 in the wrong quadrant, let's say you plotted number 1 in quadrant 4, and then you got to the bottom and you did 360 minus the reference, you're going to get that point there, right? So what I'm going to do is follow your mistake now. It's not like you graphed it wrong in number 1 and now you can't get any of this, right? I will look at it and figure it out. Is that your question? The directions will say 0 to 360 or 0 to 2 pi. So it's like, how do you calculate that without saying, change your calculator to degree mode? You know what I mean? If it has pi, go radians. If it has a degree symbol, go degree. All right, so this is the third open-ended. You saw there was one with the unit circle. You saw that there was one with the sine cosine curve table. This is the third one. The only unit we did not talk about together was the very first unit. There is only one question on the final from the first unit. So I'm going to make today really brief because I think there's more benefit in you having practice time than listening to me talk, all right? But just so you can see an example of what that very first unit looked like. On page 2 of this, it's just basic factoring examples. If you can't basic factor and you have gotten to this point of the class, congratulations. I don't know how you've gotten here, but good job. You have faked it, all right? You have to be able to factor tomorrow to do so many things, right? That whole graphing unit, you have to factor, all right? So this factor, I'm looking for things that multiply to negative 72. And add to 1. You're right, it's 8 and 9, right? So, positive 9, negative 8, right? So what I'm doing here is I'm going to the calculator, I'm doing negative 72 divided by x. I'm not physically doing that, but that's what you would do, right? And then you're looking at the numbers side by side and seeing what adds to 1. Those two numbers are positive 9 and negative 8, so that's factored for me. That one's pretty basic. The next one is called perfect squares. To factor in perfect squares, you take the square root of each term. So the square root of 16 is 4. and the square root of x squared is x, and the square root of 9 is 3. When you factor in perfect squares, the factors are the same but opposite. So that would be like a 4x plus 3, a 4x minus 3. The process of the factoring for 1 and 2 are different, right? They're different methods. The next one's a little bit tougher, so I'm going to do negative 96 divided by x. Anybody know where that 96 is coming from? 4 times negative 24. I gotta take into account the first and the last. And I'm gonna look for things that add to negative 29. Let's see, negative 96 divided by x. Negative 32 and positive 3. Alright, so we've got negative 32 and positive 3. So what you do is you split up that negative 29 into those two numbers you chose, right? So negative 32 times 3 is negative 96, and negative 32 plus 3 is negative 29x. So I'm just splitting up that middle term. This is called factor by grouping because the next step is to group these in pairs and divide out their GCFs. So divide out what they have in common, which is different for each parenthesis, right? Each pair has its own GCF. And when I divide that GCF out, I should get matching things in the parentheses. So this is x minus 8, and this is x minus 8. And then the final thing is to bring the GCFs as one of my factors, and the divisors, what I got out of it, as the other factor. Okay, going? All right, and the last one, everyone's favorite, is SOAP. Same, opposite, always positive. Instead of taking the square root, we're going to take the cubed root of these things. The cubed root of x cubed is just x. Now to get the cubed root of 729 on your calculator, you can hit math and there's a cubed button down at number 4. So the cubed root of 729 is just 9. Alright, so here's how we factor this. The first set of parentheses is one of each, and the symbol is the same as the problem. So it's x and 9, and the symbol is the same as the problem, which is plus. So that's the first factor. The second factor is this squared, these together, and this squared. The symbols are opposite and always positive. So in the second set of parentheses, we're squaring each, and then the middle term is putting them together. And the thing is, that's not even like the questions on the test. The question on the test looks like below it. See the number 1 at the bottom? That's what the question on the test looks like. Like, we're multiplying these, what do we do with them? All right, so what I would do is I would take all of these factors, so like this example here is all of the ones we just factored. I would take them all and I'd put them in factored form. And then what I would do from there is I would cancel out, well, I'd find first the restrictions, right? X cannot be anything in the denominator, right? X can't be negative 3/4. X can't be positive 8. X can't be negative 9. This one, if you graphed it, doesn't intersect the x-axis. You could do quadratic formula on it. You're going to get a negative discriminant. Okay, so there's there's no restriction here. Alright, so I'm saying the restrictions from the bottom, and then I'm canceling out anything top and bottom that matches. So like I've got these x minus 8s. I've got a 4x plus 3 and a 4x plus 3. I've got an x plus 9 and an x plus 9. And then I'm just writing what's left. With or without parentheses, it doesn't matter.
Is this one over 90s?
This is that one multiple choice. One. You gotta factor 4 problems and then cancel things out. One multiple choice. It's a lot of work for one problem, but that's it. It's just one. Although, think about what would change though, guys, if it was division. Right? So like that first example is multiplication. If it were division, you'd have to keep the first fraction the same, change division to multiplication, and flip the second fraction, and then repeat. Factor everything, cancel out. Right? That would be the difference. You might see it in terms of multiplication, but you might see it in terms of division. And you need to know that there's a difference there. It's keep, change, flip if it's division. Now, I went ahead and factored these for you just to save time. But if I kept the first fraction the same, this was my factor. 6x minus 5. I did soap on this. The first fraction stayed the same. So I didn't change anything. But when I flip the second fraction, that x minus 8, x minus 2 goes to the bottom. And this goes to the top. So with keep, change, flip, that second fraction flips. And then from there I find the restrictions and cancel some things out. So I see that I've got a 6x minus 5 and a 6x minus 5, a 6x plus 5, a 6x plus 5, an x minus 2 and x minus 2. 36x squared plus 30x plus 25 all over x minus 8. X cannot be negative 5, 6, positive 5, 6, positive 8, positive 2. Right, the denominator is your restrictions. The only thing different between those two things, keep, change, flip for division. What about that?
Is the second term in the trinomials that you get after factoring the cube root? How do you get the second term?
I'm taking my 2 cubed roots and multiplying them together. So I took my 6x and my 5 and multiplied them together. That's the 30x. You're talking about this second group, right?
Yeah.
So like my first term is the first term squared.
Yeah.
My last term is the last term squared. My middle term is multiplying them together.
Okay.
6x times 5 is 30x.
Okay.
So it's like merging the two terms. One multiple choice problem from that unit. Just one, all right? So all of our units, just in order, was this, right? Simplifying rational expressions, you're looking at one. The second 2 units were so similar, we were doing the graphing and the analyzing, the domain, the range, the intercepts, the asymptotes, all that, right? That's probably, you're looking like 7 multiple choice questions in there, right? We practiced a lot of that yesterday. The third unit was trig with a calculator. Trig without a calculator, sine and cosine curves. So that's the whole year, right? You know what the open-ended are going to look like. We've done practice with the multiple choice. If you're curious what the multiple choice is going to look like, go through your TAN packet. Every day we did a warm-up that was multiple choice practice. That was practice for the multiple choice part of the exam. So you can see that. All right, I have 2 extras. I know some of you like to do it again, but if any of you want to look at the multiple choice again. Here are my options for you for the next 20-ish minutes. Option 1 would be, we have this just traditional pencil and paper review guide. The answer key for all of it is on Canvas. Option 2, I created an open-ended practice. It's on Canvas. It's 3 problems. It's the same 3 problems I told you with different numbers than we've practiced. You can go through Google Slides and do that practice. The answer key is as you go, so you can just check as you go. One more time. The final exam is tomorrow. Just saying it one more time so we're not surprised when we come in and I hand you a final. Even juniors. Final exam is tomorrow. Alright? So you have the rest of class to pick one, work on it. Keys are on Canvas. Everything you need is on Canvas. I have 2 extras if you want to do the multiple choice practice. I have 2 extras here too. Sure. Alright, so when I give you an angle, those are angles. You're giving me a coordinate. I'm looking for your answer to be 1 half, 3 over 2, 2 over 2, 1, 0, something like that, right? So, normally I'd say, okay, well, where's 4 pi over 3? And let me just figure out what the coordinate is, but there's no 4 pi over 3. So we're going to find a reference angle. The only possible reference angle would be pi over 3. Because there's not really pi. Does that make sense?
Yes.
Alright, so my reference angle is pi over 2. So I'm looking at the coordinate. But my answer is going to be one of those 2 things. Because it's sine. It's going to be y value. The only thing you have to do from here is decide if that should be positive or negative. And that's coming from this 4 pi over 3 is a more than 1/3 is more than 1. Less than 1 1/2, right? Is quadrant 3 and 2. Now, tomorrow, strategy. That's a radian. All you have to do is pick the options. So let's say one of the options is root 2 over 2. Type option A. And see that that decimal doesn't match. It can't be that. You know what I mean? So you can use that to work your way backwards. Yep. Will and Isaiah, your tests are already there. So when you don't have to come here tomorrow. You can just go right to this file.